If you're a Delphi developer, you've been there, staring at your screen asking that timeless question, should I be using free, dispose of, or FreeAndNil? Man, it's a dilemma that has tripped up even seasoned pros for years, especially when you're trying to make your code work everywhere. Well, today we're going to put on our detective hats and solve this memory mystery once and for all. Let's get into it. So here's our game plan. First, we're going to investigate the scene of the crime, a real tale of two different memory worlds. Then, we'll dive into the age of automatic reference counting, or ARC, and see how its simple promise led to the confusing rise of Dispose of. After that, we'll see how the whole case was finally cracked with a unified memory model. We'll also cover exactly why your code is still king, even on Android, and we'll wrap it all up with a clear, simple action plan for modern memory mastery. All right, let's set the scene. For the longest time, the real root of this whole mystery, the reason we were all so confused, came down to a deep split right in the heart of the Delphi universe. You know this feeling, right? This is the question that drove so many of us nuts. You build a fantastic VCL app for Windows. It's solid as a rock. Then you take that same logic, recompile it for Android or iOS, and boom, out of nowhere, you're getting weird crashes, slowdowns, and memory just seems to vanish into thin air. So what on earth was going on? Well, here's the culprit. For a while, Delphi was living in two completely different worlds. On Windows, we had our classic, predictable, manual memory management, backed by the incredibly efficient FastMM. But on mobile, to kind of fit in with how those platforms worked, Delphi adopted automatic reference counting, or ARC. Two different systems meant two totally different rulebooks, and that was ground zero for all the confusion. So let's take a closer look at why ARC even showed up in the first place. Honestly, the intention was really good. It was all about trying to make our lives as developers a little bit easier on mobile. You know, the idea behind ARC is actually pretty brilliant. The compiler basically becomes your personal bookkeeper. Every time a variable points to an object, a little counter goes up. When that variable isn't needed anymore, the counter goes down. And as soon as that counter hits zero, poof, the object just disappears and its memory is reclaimed. The dream was no more manual cleanup, or so we thought. And this right here, this is what they were selling. On the left, you've got our old reliable friend, the try, finally, free block. Yeah, it's a little wordy, but you always knew it had your back. And on the right, that was the ARC dream. You just create your object, you use it, and then you just walk away. The compiler handles all the messy cleanup. It was supposed to make our code so much cleaner. But then came the plot twist. Turns out, taking a seemingly simple idea like ARC and trying to bolt it onto a framework as rich and complex as Delphi's, well, that had some really deep, unexpected side effects.
And this quote from Alan Bauer, man, it just hits the nail on the head. It gets right to the core of the problem. You see, in Delphi, a destructor for something like a T component does way more than just free up memory. It has to tell its owner it's going away. It has to unhook notifications, all this complex housekeeping. And that created a massive headache for ARC.
This was the nightmare scenario. Strong reference cycles. Just picture it. A form owns a button. That's a strong reference, pointing from the form to the button. But the button also needs to notify the form when it's clicked. That's another strong reference, pointing right back at the form. In the world of ARC, these two objects were locked in a memory-leaking embrace forever. Neither of their reference counts could ever drop to zero. And so, to solve this, Dispose of was created as this emergency workaround. It was basically a sledgehammer. When you called it, it would just force the destructor to run right then and there, breaking those cycles. But, and this is the really weird part, the memory wasn't actually freed yet. The object would enter this bizarre zombie state. Its destructor had run, but its memory was still hanging around, waiting for its reference count to finally trickle down to zero. It worked, but man, was it confusing. Okay, so things were a mess. This whole confusing situation just couldn't last forever. And thankfully, a huge decision was made that completely changed the game for the better, solving this whole case for good. This timeline shows you the exact moment everything changed. Before Delphi 10.4 Sydney, we were all living in that broken world of confusion. But with 10.4, a hero arrived, the Unified Memory Management Model. One set of rules, one consistent, predictable way memory works on every single platform Delphi supports. No more guesswork. So let me be perfectly clear, because this is the most important part of the whole story. The main villain, the primary source of all this pain and confusion, automatic reference counting for objects on mobile platforms, is gone. It's history. Your code now behaves the exact same way everywhere you deploy it. Which finally brings us to the solution of our big mystery. What is Dispose of today? It's nothing more than an alias for free. That's it. It does the exact same thing. It's only kept around so that older projects don't suddenly break when you recompile them. But for any new code you write, just use free. It's clearer, it's cleaner, and the debate is officially over. Okay, so the case is closed on Dispose of. But this brings up a whole new question, one I hear a lot from Android developers. If we're on Android, why can't we just kick back and let the system's garbage collector clean up our mess for us? This right here is one of the most critical things to understand. When your Delphi app runs on Android, it's a native app. All your objects, your T-string list, your forms, your T-bitmaps, they all live in what's called the native heap. Think of this as a totally separate country from the Java heap, which is where objects created in Java or Kotlin live. The Android garbage collector, it only has a passport for the Java heap. Let that really sink in for a second. The garbage collector is completely, 100% blind to your Delphi objects. It has no idea they even exist. So this idea that the system will eventually sweep in and save you is a total myth. If you create an object and you forget to free it, that memory is gone for good, leaking away until your app finally gets killed. And this leads to a really sneaky but deadly problem called memory fragmentation. See, the native heap can't be neatly packed down like the Java heap can. So every time you create and destroy objects of different sizes, you're leaving behind little holes. Over time, your memory map starts to look like Swiss cheese. You might have tons of memory free in total, but you don't have a single continuous block big enough for that new high-res image you need. The result? A frustrating out-of-memory error, even when you technically have plenty of memory left. So you see, managing your own memory isn't a chore. It's your superpower. It gives you way faster performance. It stops those annoying random crashes, and it helps you avoid fragmentation. It also keeps you off the radar of Android's low memory killer, which loves to shut down leaky apps. And get this, by being efficient, you use less CPU, and that directly translates into longer battery life for your users. It's a huge win. All right, we totally get the why now. So let's roll up our sleeves and get to the how. Here are these simple, clear, best practices for memory management in modern Delphi, no matter what platform you're targeting. This right here is the golden rule, the one pattern that should become pure muscle memory. Anything you create, you must, and I mean must, wrap its use in a try.finally block. And your call to free always goes in the finally section. This is your safety net. It guarantees that object gets freed, even if some crazy exception happens in your try block. Seriously, no exceptions to this rule. Now let's take that golden rule and level it up. Calling .free is good practice, but calling FreeAndNil, that's best practice. Here's why. .free destroys the object, sure, but your variable's still pointing to that old dead memory location. If you accidentally try to use it again, your app crashes with an access violation. FreeAndNil is smarter. It does two things. It frees the object, and it sets your variable to nil. It completely wipes out the risk of these dangling pointers. It's such a simple change that makes your code so much safer. So, we've established that being a great destructor, always cleaning up after yourself, is absolutely fundamental. But I want to leave you with one last question to chew on. For those really high-performance apps, the ones creating and destroying thousands of objects a second, maybe the ultimate level of mastery isn't about destroying things at all. Maybe it's about becoming an excellent recycler, using patterns like object pooling to reuse objects instead of constantly asking the system for new memory. How can we shift our mindset from a create and destroy cycle to more of a borrow and return model? Something to think about. Thanks so much for joining me.